All right, everyone, this is lab one. How I used to do these labs was I would have a demonstration in front of the class. I'd kind of work through the lab, and then the students would take the written description of what to do, which would be basically a set of basic instructions, not necessarily step by step, but sort of do this part now, do this part now, do this part. So I wouldn't exactly say where to click. You'd kind of have to pay attention to the demo, and then you could ask me questions if you couldn't remember how to do something. But this is a little bit different. I did start doing videos at one point when there were really difficult spots. So this will be kind of like that, except for we're just going to work through the whole thing in the video, and then you can follow along. And in most cases, we'll have kind of not necessarily a challenge at the end, but a part where you do much of what we did in the demonstration part. Um, you do that yourself, but sort of a different version of it, slightly modified version of it. For this first lab, I'm just going to go through the steps here and have you follow along, and then submit your responses. And so you'll have some responses to questions, and then you'll also have a map that you create that looks a little bit like this. And all I really need is just a snippet of what you produce, like this. If you don't know, there is uh, the snippet tool. So if you just search for that, snipping tool, sorry. So you can use a snipping tool to snip out your map. Um, and later on, we'll get into making regular maps with a legend and a north arrow and all that stuff. But for this one, I really just want you to, we're going to download some data, and then we're going to do some basic geoprocessing with vector and raster data. Okay, so I'm going to do this with Santa Cruz County. You can choose any county you want to, but maybe choose a smaller county because the data sets can be quite large. So I wouldn't go much larger than Santa Cruz County. Okay, so the first thing we need to do is to set up our project. So I want you to create a folder called Lab 1. So for each of your labs, you're going to have a folder, Lab 1, Lab 2, Lab 3, right? And inside that folder, you will have your ArcMap document and your database, okay? By doing this, you set it up so that when you move your project, as long as you move the folder with the database and the map document, as long as you move those things all together, everything should continue to work. If you take your map document and you email it to yourself, or you store it on your flash drive and your database goes in a different place, then those two things will break apart, and you're going to be sad when you open up your map document and you can't find your data, because the way that GIS works is it's a little bit like a web browser. The data are not stored in the GIS. They're not stored in ArcMap. They're not stored in that project. They are stored separately somewhere on your hard drive. So what ArcMap stores is paths as a path to your data, but not the data inside ArcMap. Okay, I'll explain this a little bit more as we go, so you can kind of see it in action. But know this: you need to create a folder, put your map, save your map document, and your database in that folder. Okay, so then everything will stay nice and tidy, right? So so in the first step, we're going to create a new folder called Lab 1. And we're going to create a new file geodatabase called Santa Cruz County. In your case, if you're not doing Santa Cruz County, call it San Francisco County, call it Amador County, whatever. Okay, it's got to be California County. All right, so let me go ahead and go to ArcMap. So we're going to start a new blank project. So I can either close this out or say OK because it's a blank map. And right away, I'm gonna save it. So save as, and I'm going to put it in Documents, Foothill, Data Acquisition, 2019, Week 1, and I have Lab 1 here. So I'm going to go in here and say Lab 1 and save it. Okay. And then I'm going to go to So I already had the lab one folder. You're going to have to create that yourself. Um, Let me close this because it's something that you're going to need to learn to do if you don't already remember is to create connections to your folders. So, so you would right click on folder connections and say connect to folder. So let's go ahead and I'm going to connect to lab one if I can get there. Documents. You don't necessarily have to have your files organized like I do. Just as long as you have um, your files in a lab one folder, right? So now I'm connected to this folder as soon as I say OK, and there it is, and everything inside that is right here. So you can see the lab one document that we just created is stored in there, and now I'm also going to create a new geodatabase. So if I right click on the folder there, I'm going to say new file geodatabase, and I'm going to right click on that, go to properties, and I'm going to call it, well, scratch that. Just highlight it. Santa Cruz County. And this is kind of tricky so right now I did one click to make this show up as blue to highlight it, and then another click, kind of a slow click to get it to get to this state where I can then edit it, okay? So again, click once and then click again, another slow click, and it goes like that. And you can type Santa Cruz County or Amador County or Kern County or Los Angeles County or whatever. Okay. So now let me just go ahead and save this again. So in case something crashes, a good idea with all the Esri products, any GIS really, they're prone. It's complex software. It's prone to crashing. So save frequently. Okay. All right. So let's go back here. And now I want you to download the California county boundaries from the California Natural Resources Agency. So if you just click on this link here, it will open to this page. And this is pretty slick. You can actually see the data set before you download it and kind of interact with it a little bit. If you go over to here to the right hand side, you can click on the download button, and we want the shape file. KML would open up in Google Earth. Spreadsheet is just the attribute table, but we want the shape file. Okay, so click on that. I'm going to save it to downloads. All right, now I'm going to open this up and extract it. So look at what this looks like. It's a shape file. So in the GIS it'll look like one thing, but in Windows Explorer it's actually several files. So it's a composite. So a shape file, for the most part, we're going to be dealing in this class with geodatabase feature classes. Shapefiles are kind of an older format. They're still in use. They're still useful, but they don't have a lot of the functionality that we can have with a geodatabase feature class. But in any case, it's a composite file. It's a bunch of things that kind of work together as a single thing within the GIS. So the .shp is the geometry. That's the points, lines, or polygons. In this case, the polygons are stored in here. This is the projection file. It is a description of the coordinate system and projection that is used in this data set. This is the attribute table, the DBF. This down here, the .shx, is the spatial index, so it sort of speeds up it speeds things up when we do selections or query the data at all. And then these other things are extra stuff, so we won't get into those. But these are critical. These are the critical parts. The the spatial index, the geometry file, that's the SHP, the PRJ, which is the projection file, and the DBF, which is the attribute table. Okay, so I'm going to close that for now and go back to my GIS here. And I'm going to go ahead and connect to my downloads. Let's see. Downloads. Say OK. And there's my California counties shapefile. Look at that. So you see the XML there, but all those other files sort of come together as one shapefile within the GIS. So I can take this California county shapefile and I can just drag it into my table of contents. And there it is. Okay, so you might not be used to looking at the state of California as much as I am. I've looked at this file many, many times. I can tell you that this looks sort of squished. It should probably look a little bit squished to you. Kind of flat and yeah, wider than it should be. That has to do with the kind of projection that we're using. I'm gonna say that this is more than likely. If we go to the properties, so I just did a right click on the layer. It's taking a long time. Okay, if we go to source, we can scroll down. And so the geographic coordinate system, which geographic coordinate system, a geographic coordinate system is a system of latitude and longitude, is it's WIGS 84. So basically this is in latitude and longitude, so it's not projected. The units here are in degrees, and almost always, if it's in latitude and longitude, things look a little bit squished. Okay, so we want to take this shapefile and we want to put it inside our Santa Cruz County geodatabase. So we'll store it there as a geodatabase feature class instead of a shapefile inside a folder. So let me make sure I'm following my own instructions and see. Okay. So we'll do this here in a few more steps. But right now, let's go ahead and get our elevation data and our streams data from the USDA Geospatial Data Gateway. So that's here. So once you're on the Geospatial Data Gateway homepage, you can go ahead and order data by clicking on this big green Get Data button. And then we're going to select our state, California, and then which counties we're interested in. In our case, we want Santa Cruz. Okay. And then you can see there's all kinds of data, climate data. There's our elevation data. I'm going to go ahead and click the National Elevation Dataset. That's NED. The NED dataset, 30-meter resolution. So that means that the cells in a raster, the little squares, are 30 meter by 30 meter. So it's fairly coarse. And then I'm going to come down and get the hydrography data. So this is streams and lakes and that sort of thing. And then you can also see, if we wanted, we could get land cover data, we could get soils data, transportation data, and others. So then we're going to click continue, and I'm going to select the format that I want. So I'm going to say file geodatabase, and then I'm going to say continue. And then it asks for my email, because what they're going to do is they're going to send you a link. So yeah, put your email in, click continue, and then when you open up your email in so many minutes, you'll see that they sent you a link that you can download the data from. So I'm going to click continue. And since I just did this to test it, it says there's a duplicate order detected. So I'm going to say OK. But you would go down over here and say place order, and then they'd say how many minutes it was going to take before they sent you the link to download the data. Okay, so now I'm going to go to my email since I already have it. And down here, it's kind of a confusing email to read, but you come down to ordered items. Oops, I didn't mean to click on that. Close that. Okay, so go down to ordered items, and then you can see here's our national elevation dataset 30 meter, and then our national hydrography dataset. So I'm going to click on this one first and save it to my downloads. And then I'll do the same one for the second one. Save it to download. Okay, I'm going to open the folder. And there they are. So let's go ahead and extract this one. Okay, and I'm going to extract, oh, that was the elevation. Extract the hydrography. Extract all. All right, so you have to extract them before you can access them in the GIS because the zip file won't be visible inside ArcMap. So now I can, since I have the downloads mapped, I'm just going to right click on this and refresh it. So now you can see I've got my elevation and my hydrography. So I'm going to take the data in here and I'm going to bring them into my lab one folder. So hydrography, let's expand that. And you can see that there's a bunch of different layers inside this geodatabase. So here's the geodatabase, and then right here we have a data set. So a data set is a collection of features within the geodatabase that all have something in common. So it's almost like a folder inside the geodatabase. It's not really a folder, but it's a grouping of data. We can kind of think about it maybe like a folder. So the one we want, I think actually if we bring in the streams here, oh, I don't know why that's not showing up. Remove that. Okay. Go ahead and should be this one here. And it says that it's in a different, it has different coordinate information than what exists in here. Just go ahead and say close. It's okay for now. And now we can zoom in. And you can see that our streams match Santa Cruz County. We've got some streams that overlap, so we're going to clip those to our counties, okay? So that we have streams just within Santa Cruz County and not kind of extending out beyond the county boundary. So for now, let's go ahead and bring our raster data in. So I'm gonna minimize that there, and then here we have elevation, and here we have 4 rasters. So we're going to have to take these and combine them into one. So I'm going to go ahead and click on all of them. I'm going to do a shift and, oh, you can't do that inside ArcMap. If you go, so you can only select these one at a time in this view of the catalog. But if we come up here, I'm going to hover over here, it says toggle contents panel. So I'm going to click that and go up one. So there they are. So for this elevation folder, I can grab all of them and drag them in all at the same time. And it's giving me the same error, but we can close that for now. Okay. So let's see. I'm going to make this. So there's my county boundaries, and well, let's make the NHD data blue. So I'm going to make the streams blue. If I just click on the symbol here, then this thing comes up. I'm going to select river. I could have just selected any color here, but that's easy enough just to select river there. And there they are. And then you can see if we symbolize these differently, I'm just going to kind of randomly pick these here. You can see that they're all 4 sort of seamed together. There we go. And then the last one kind of looks like Andy Warhol artwork. Okay, so we need these to all be one layer. So we have to take these 4 rasters and we're going to mosaic them together, and then we're going to clip them to the county as well, right? So let me make sure I got my order of things right. Let me go look at my instructions here. Okay, so we're going to bring. So we downloaded our data. Now we're going to bring California counties into our Santa Cruz County geodatabase, and I'm going to do the same thing basically with the raster data and the stream data. Although in this first one for the counties, we're just going to import it directly in. For the other two, we're going to use geoprocessing processes, and the outputs are going to land inside our geodatabase. Okay, so let's go ahead and do this first step. We are going to I'm going to turn these off for a second. And I'm going to right click on California counties, and let me do this a different way. So let me go to my system toolboxes and conversion, and I want to use feature class to feature class. Okay, so my input features are going to be California counties. And my output location is going to be, oh, ignore that. You probably won't get that error message. It's, okay. So California counties, and our data are in downloads. Oops. Oh, that's not what I meant to do. I'm going to the output location. Folder connections, lab 1. That's my Santa Cruz County geodatabase, and I'm going to say add. So there's my output location. As soon as the wheel stops spinning. Okay. And the output feature class, we'll call this California counties. The names, the name of a feature class cannot have spaces in it. So we could have underscores like this, but we cannot have spaces. So I've done what's called camel casing. So I've put California and counties together in kind of one word, but you can see that the county starts with a capital. So it's easier to read. So again, that's called camel casing. And we're going to accept the defaults and go up here. Oh, I want all my outputs to be in a common coordinate system. So I'm going to do this, and I'm going to say environments and output coordinates, and I'm going to change this to come on. No. Why won't it let me select a different coordinate system? Transformations. Huh. Oh, as specified below. So I want California TL Albers. Okay. Say okay. And my workspace, we won't worry about this. I mean, ideally this would probably be lab 1. You can ignore this for now. The main thing in this environment, we just want to change the output coordinate system. So let's say okay. And so now when it brings the data in, it won't just bring the data in as is, it'll actually reproject it to TL Albers. I'll explain what that is later, but for now, just go to environments again, go to output coordinates, choose as specified below, Ignore that. And then here you should be able to find California teal albers. And I just realized that this is easy for me because it says favorites, but for you it won't say favorites. So you should go to projected coordinate systems and then state systems and then down to California, and you'll find it. Oh, not the NAD 27 one. We want the NAD 83 one. This one. NAD 83. Oh, darn it. There's so many of these. This one. Sorry. NAD 83. NAD 83 California teal albers in meters. Okay. So do that one. Say OK. All right. And then we say OK, and it should run. All right. You don't have to worry about this in this particular case. So now you can see it added the new California counties to my table of contents. I'm going to delete the old one. And if we look here at the source, you can see that this California counties is coming from the place where I put the output. Okay. And if we were to, let me go back to the other view. If we were to right click and look at the properties, we can see that under source, the coordinate system is the projected coordinate system is California teal albers. Okay. All right. So now we want to get our streams into our geodatabase, and how we're going to do that is we're going to clip our streams and we're going to put the output inside the geodatabase. So the way to do that is to use the clip tool. And we want to clip just to Santa Cruz County. So this is where selections can become very handy. So what we're going to do is we're going to select Santa Cruz County. We're going to run the clip tool, and it's going to work like a cookie cutter and cut the streams that are just inside Santa Cruz County, and they're going to put the output into our geodatabase. So first thing we want to do is go to our selection tool here, and I'm going to select the area. I'm going to try not to select a stream. Just select the county like that. And then I'm going to go to Analysis Tools in my toolbox. Again, this is Toolboxes, System Tools, Analysis Tools, and then I'm going to go to Extract and Clip. So our input features are going to be the streams. Our clip features, that's going to be California counties. So then our output feature class is going to be let me make sure this is going to the right spot. Be careful, you don't want to put this in the default geodatabase. You want to make sure you're putting it into your Santa Cruz County geodatabase, okay? So let me go ahead and make sure that's going to the right spot. Folder connections, lab 1, Santa Cruz County, and I'm going to call this Santa Cruz Streams. Save. And we don't have to worry about the XY tolerance here. The default is fine. And I'm going to let that run. Oh, one thing I want to make sure, if I go to environments, I want to make sure my output coordinates are the same as, the same as my California counties. You can either set this to teal albers as we did in the last step, or you can just say same as layer California counties, because that as we just did, is set in California teal albers, right? So that should be fine. And then I'm going to go and say OK, and then run the tool. All right, there's my new streams. So I'm going to get rid of my old one, remove. And then if we right click and we look at the properties here, wait for a little while. All right, so projected coordinate system is NAD 83, California teal albers. All right. Say OK. And then if we go up to our geodatabase, I'm going to refresh this. That was a right click, refresh, and expand it. And now we see we've got our California counties and we've got our streams. And if we zoom in, let's see, I'm going to unselect here. You can see that the streams go just to the border of the county and not beyond. So we're just working within the county boundaries. Okay. So I'm going to save my project. And then the next thing we want to do is get these, change the symbology on my counties back to what it was. Okay, we want to get these 4 rasters to all become one. We want them all to be one raster, and we also want them in that teal Albers, right? So let's go ahead and we're going to run the mosaic to new raster tool. So if we go to System Tools and we go down here to Data Management Tools and then down to Raster and Raster Dataset and mosaic to new raster. So now we can take our 4 elevation rasters and just grab them all and drop them in there like that, and then specify the output location. Output location. And I'm not going to put these rasters inside my geodatabase. I'm just going to store this in my Lab 1 folder, because rasters, they don't perform. There's certain situations where you want to put rasters inside the geodatabase, but for what we're doing here, I think it's better to keep them out. So I'm going to say my output location is the Lab 1 folder, and say OK, and then we have to give it a name. So I'm going to say elevation 30 meter for 30 meter resolution, and then I'm going to say this is a .tiff, so it's a TIFF file. It's a GeoTIFF. Spatial reference for the raster, we want to use that California teal Albers. We want that to be our output. So I'm going to go, I could either select it there, or I could go to State Systems and then scroll down to NAT83 California teal Albers in meters and say OK. And I want this to be not 8-bit unsigned. I think actually, I don't think I can. So some of these values are negative. So we want the values to be negative and positive. And then we need the values to go up to at least, we want to, 8-bit only goes up to 256, right? So this value here will not be able to be stored in an 8-bit data set. So, and the fact that it's unsigned means positive only, positive values, no negative values. So we need to choose something different. If we choose integer, then all our values behind the decimal point will get dropped. It's not that big a deal in this case, but we might as well accommodate that. So I'm going to say 32-bit float. That'll give me the positive and negatives, and it'll allow me to keep the decimal point, and it'll go to values much larger than 1789. So 32-bit float is great. The cell size, we'll leave that as the default. The number of bands is 1. I'll explain what bands are later. And then it's okay for us just to accept the defaults here in terms of the color map and the mosaic operator. So we'll say, if we get everything set just like this, we can say OK. And it chugs through it. By the way, you may not see this window show up like it is in mine. I can show you how to make that happen. By default, I don't think ArcMap does that anymore. They do this thing called background processing, which has some benefits, but I don't like it. So well, the reason that shows up on mine is because I went to geoprocessing and then geoprocessing options, and I disabled background processing. So more than likely yours is checked, and that's why you're not seeing those windows open when you run the tools. Okay, so now let me get rid of these. Remove, and you can see that this is our one and only elevation raster. Let me choose something different than that. That's kind of hard to look at. It's also bad. Single color. Okay. All right. So now we're going to extract the raster. Basically, we're going to do a clip like we did for the streams. We're going to do it on raster. So it's a different tool. Um, for this, we're going to have to use the spatial analyst tools. So this is an extension, and in order to get the extension to work, you need to make sure that the extension is checked on. So let me do that again. If you go up to Customize and then Extensions, you can see that there's a set of your sort of set of extensions, and you want to make sure that Spatial Analyst is checked. And once it is, these tools will all work. So for this one, we're going to go down to Extraction, and we're going to use the Extract by Mask tool. So our input raster is elevation 30 meters. And then our mask data is going to be California counties. But I need to make sure that this one is selected. Let's see if I can do this while this window is open. All right, so with that selected, it should do exactly what we want. It'll clip the raster to Santa Cruz County. And then we want to make sure this goes to the right place. So I don't know why that's happening. So I'm going to store it outside, and I'm going to call it elevation 30 meter Santa Cruz. Save it, and then I'm going to run this. The output should be in teal hours because the input was. And there it is. And now I can turn this one off. Let's clear that. That's the unselect, right? Or deselect, as people who use Photoshop say. And there you go. That's more or less what we wanted to do. To kind of color it the way I have in the picture, something like this. I'll make that white, right? This border's a little bit more visible. Let's change our streams to a different color. Streams to blue. Do a light blue. And then bring our elevation up on top of our counties so it looks more or less like I showed it in the exercise. So this is what we did. We imported California counties into the Santa Cruz County geodatabase using the feature class to feature class tool. We called the output Santa Cruz County, so that's fine. We used the mosaic to new raster to merge the elevation rasters together, and then we use the extract by mask to clip the raster to Santa Cruz County. So in order to do that, we had to select Santa Cruz County, the Santa Cruz County polygon, and then run the extract by mask tool, and then we use the clip tool to clip the streams to Santa Cruz County. So we selected Santa Cruz County, then ran the clip tool, and it got us what we wanted. I think I need to change this. We're using oh no, that's right, sorry. Okay. All right. And then the last step is just to use the snipping tool in Windows. That should be capitalized in Windows to take a picture of your map. And then I want you to answer the following questions down here. So list the projection of each of the three layers in your table of contents. So you're going to go to the properties of each of the layers to do that. Right click on the layer in the table of contents, go to properties, and then source. What is the projection listed in your data frame? So let me talk about that for a second. This is your data frame where it says layers. So this is where all your GIS layers are being housed. And so this is like the piece of paper basically that everything is sitting on. And so each of your layers will have their own coordinate system associated with themselves. These can all have different coordinate systems and lay on top of each other just fine because they all snap to the coordinate system that is the grid on the piece of paper. So if we right click on this data frame and go to properties and go to the coordinate system tab, let me click on the coordinate system tab, then you can see The coordinate system is geographic coordinate system. That's GCS WGIST 1984 in this case. And so everything is snapping to that. If I wanted to, it would kind of make more sense if I were to say, go back here and change this um, let's go to TL Albers. So that's state systems, California, TL Albers, US. I want meters. I want NAT 83 California TL Albers in meters. So I say OK. And you can see it shifts a little bit. The shape changed. If we zoom way out, you can see that California doesn't look squashed anymore. It looks a little bit more like you would expect California to look. Okay, and zoom back in again. Okay. Oops. I'm going to hit this little blue back button. So this is going back to the previous extent. Um, so just tell me if you go here and more than likely it's going to be the GCS WIGS 84. But just know that the data frame, that is the piece of paper, can have a different projection than anything in here. Usually it's going to be the same as at least one of them. The way that the projection for the data frame gets set is when I bring a file onto this piece of paper, onto this data frame, it sets the coordinate system for the data frame, and every other file that I bring in after that will snap to that coordinate system, regardless of what coordinate system the data are actually in. Okay, so, and then I want to know what are the minimum, maximum, and mean values, that is the average value, for your elevation raster. So with this raster here, we can go to Properties and scroll down. And it gives the statistics for the raster. So the minimum elevation, the maximum elevation, and then the average elevation, and the standard deviation of elevation for the data set. Okay, so again, that was if we right click on the raster, go to Properties, and that's under the Source tab. All right. And then what is the pixel type for your mosaic elevation raster? Is it integer, floating point? What do we have? And lastly, is there an attribute table for your mosaic elevation raster? I should show you. That's under the Source tab as well. So if you go back to here and right click and go to Properties, you can see that this one happens to be floating point. So it should say floating point. And then, is there an attribute table for your mosaic elevation raster? So I'm going to let you answer that question, and then briefly explain why you think rivers and counties are in vector format while the elevation layer is a raster. So you might have to refer to the lecture to get that answer right. So let me just show you real quick how you would find an attribute table. So if we go to the Santa Cruz streams layer, we can go and see open attribute table, right? So you want to do that for your raster and see what you get. I'm going to remove this and just have these are the layers that matter for the project. Oops, don't zoom. Okay, back to previous extent. I just wanted to pan that over like that. All right, so basically I just want you to follow along. There's no real challenge to this. It's just to do what I do and then answer those questions. It should be pretty straightforward, but let me know if you have any problems, and I'll try to get back to you as soon as I can. All right, good luck. Thank you.